Alrighty, hi guys, it's me again. I am really just not feeling well, so I'm going to stay home again so that I can hopefully finally get over this and come back and really be ready to teach you guys. I want to talk though because it looks like there were some questions with the sub yesterday with Miss Benke. I'm sorry if I didn't pronounce that right, about the charges on those unit conversions on that number line. And so I want to remind you with my number line that I did. When I've got my base unit here, and this is what I was talking about with the signs being the way that they are. And so I'm going to just write down just a couple parts here. We'll do centimeters, because centi is something that you guys kind of know. And so I wanted to describe this to you. Okay, so we've got centi, or we have kilo. Okay, so remember, this side is my smaller than base unit, and this side is my larger than base unit. Okay, so centi is 1 times 10 to the positive 2. Okay, if you think about 1 times 10 to the positive 2 in terms of scientific notation, that's the same thing as saying same thing as saying 100. Okay, kilo is 1 times 10 to the negative 3, which is the same as saying 0.001. Okay? Now I know that that seems backward. I know that it seems like maybe centi should be negative and kilo should be positive because kilo's bigger, so it should be positive. But here's the deal. If you think about a meter, let's think about a meter here. 1 meter. If I have 1 meter as my base unit, how many centimeters do I have? Do I have 1/100th of a centimeter, or do I have 100 centimeters? I have 100 centimeters because centimeters are smaller. So there should be more of them in 1 meter than there should be meters in 1 centimeter. Same thing goes if I have 1 meter and I'm trying to relate it back to a kilometer. A meter is smaller than a kilometer. So I should have 1,000th of a kilometer in 1 meter, not 1,000 kilometers in 1 meter. Okay? That being said, I could say that for every 1 centimeter, that is equal to 100th of a meter, or more simply, 1 times 10 to the negative 2 meters. Alright? I think that's where the confusion is coming from. Because yes, that 2 can be positive or negative, but it depends on what you're talking about. And what I was saying is that in my number line, what I want you to do is to keep the base unit always 1. Because if you let the base unit be 1 sometimes, and other times you let it be 1,000, you get too confused in remembering, is the 3 on kilo supposed to be negative or is it supposed to be positive? If you keep the base unit as always 1, then those numbers never change. And it makes a lot more sense that way. So, at least to me, if you don't find it that way, we can talk about it when I am not laying in bed wanting to die because my head is so pressurized. We can talk about it and I'll work you through it and we can figure that out. But for now, I would like you to stick with the number line that I presented, with positive on the smaller side and negative numbers on the larger side. I hope that that kind of clears some things up right here, that 1 meter is 100 centimeters, or 1 centimeter is 100th of a meter, which would be where you're getting that negative. If we go back and talk about kilograms, or kilometers, that same way, 1 kilometer is equivalent to 1,000 meters, or 1 times 10 to the positive 3 meters. But again, I wanted to keep those meters as 1. I wanted to keep that base unit always 1. Okay? So, my suggestion right now is going to be for you to, and I'll rewrite this number line for you, but I would like you to redo your number line and have it be the way that I had it yesterday, just so that we can make sure that we're getting it right. Oh, sorry guys. So I'm going to take a quick second to redo this number line so that you can see a good number line, and then we'll move on. So this is mega, which is 1 times 10 to the negative 6th. Okay, and then we have milli over here, which is 1 times 10 to the positive 3rd, or 1,000. Okay. This is micro, which is 1 times 10 to the positive 6th. I do appreciate you guys willing to say that I was just sick and that that's what happened. That's sweet of you guys to be so kind. But this is just the way that I'd like you to do it. Again, we can talk about it when I come back. If you are dead set on doing it the other way, and that's fine. I just, for people who are going to have trouble remembering, I find that it's easier to just stick with this. So I'd like you to try it this way for today. So if the sub could go ahead and pause the video for just a second so that everybody can fix their number lines. I have new note cards if you need a completely new number line. That's fine. So go ahead and pause it. Okay, now that you're back and we're all good, I am going to take a second to go through a couple example problems with you for unit conversions, and then I'm going to have you guys work on it on your own or with partners, or however it's going to be best for you. For those of you who had chem lab methods, I would really like you to try and help out. You've seen unit conversions before, dimensional analysis. You've done this in sorry, my brain is gone. You've done this in lab methods, and so please help out your peers. Okay, so let's try doing some example unit conversion problems. So, like I said, we kind of like to start out with those train tracks. And so I'm going to draw those train tracks in. And then I'm going to put in some text. Okay. So I want to convert 3.21 times 10 to the 10th nanograms. And I want to convert that into kilograms. Okay? So that's what I'm starting with. So again, I always type in here, I'm going to type what I know, which at this point, the only thing that I know is 3.21 times 10 to the 10th nanograms. I don't want to see anybody leaving units out. The best way to confuse and screw up unit conversions is to not put units in your calculations. I know it's a hassle. I know it's frustrating. I know you're just like, banging your head against the wall. You don't want to do it. But I will tell you, the easiest way to screw up is to forget to do it. I've done it myself. I have to put those units in so that I make sure that I know what's going on. If you don't put them in, you're going to get it wrong. If you get it wrong, I can't give you any partial credit if you don't put the units in, because I can't tell what's going on. So keep those units in. Okay, I'm going to get off my soapbox here. So we're starting with 3.21 times 10 to the 10 nanograms, and I need to get to kilograms, but I am always going to convert back to my base unit. And so I'm going to convert back to grams, or my non-prefixed unit in the case of mass, because kilograms is technically the base unit. So I'm going to convert back to my non-prefixed unit, which means that I'm going to put nanograms on the bottom here, because I know that I need to get them to cancel out. So I'm going to put nanograms on the bottom, and from on my card, I know that there's 1 times 10 to the 9th nanograms. in 1 gram, right? There is a lot of nanograms, because they're really tiny, in 1 gram, okay? So now that I've been able to cancel out my nanograms, drink and drink, now I need to get rid of my grams. So I'm going to put 1 gram down here, so that'll cancel out, and I need to get to kilograms. So I'm going to put 1 times 10 to the negative 3 kilograms, okay? And then I'm going to go ahead and cancel out my grams, and I'm left with good old-fashioned kilograms, okay? Now, this is what I'm going to type in my calculator, and I want you guys to pay specific attention to this because sorry, that was so gross. I'm really sorry, guys. So at this point, I'd really like you guys to be using one of the classroom calculators, so one of the calculators from the front. If you could go ahead and grab one of those, because I'm going to talk specifically about how to insert scientific notation in this calculator, because it can get kind of tricky. So what you're going to put into the calculator is parenthesis, and I'm doing this as we speak, 3.21, and then right about in the middle of the blue keys, you'll see a button that says times 10 to the n. So you're going to type times 10, and then it's got a little n there, so you're going to press that button. And then it's got, right next to the 10, it's going to have like this flashing box where that n should be. And you're going to put 10 there, okay? So you're going to put 10. So this used to be n. Now it's not. It's not n anymore. It's not going to let me do that. It's not n anymore. It's now 10. Okay? So instead of n, it now says 10 to the 10. And you're going to close parentheses. Oh, sorry. This is the key. You're going to arrow to the right. So after you type in 10, you're going to arrow to the right with that gray oval, so that the flashing square stops being a superscript. You don't want it to be an exponent. You want it to be a regular number. And then you're going to press close parentheses. Sorry, I have to do that too. So you're going to arrow right, close parentheses. And then you're going to press divide. So divide. And then you're going to do the parentheses again. Anytime you use scientific notation, you're going to do parentheses. And here you're going to say 1. And you're going to type 1, that's important. So 1, and then you're going to hit the times 10 to the n button again. So times 10. And this time in the flashing square, you're going to type in 9. And then you're going to arrow right and close parentheses. And then you're going to say multiplied, so times. And then you're going to say parentheses 1. Press the times 10 to the n button. So open parentheses 1 times 10 to the n. In the n location, you're going to say negative 3. So remember, the negative is that minus sign in parentheses. It's a white key. Negative 3. Arrow right so that you get out of the superscript. Close parentheses. And then press enter. Okay? So you're going to do that, and you should get 0.0321. Which would be the same as saying 3.21 times 10 to the negative 2 kilograms. Kilograms. Okay? Alright, if there is someone who isn't quite getting that, please go and help them if you can. Okay? So again, the key here is, I don't know what's happening, I'm sorry guys. So the key here is arrow right to get out of exponent and use parentheses. parentheses. Okay? Can't say that enough. Okay. Alright. So next, I want you guys to try this one out for yourself, and then do it, and then we'll do it together. 8.92 feet into millimeters. Okay, so this is that whole idea of converting from metric and non-metric. And I'm going to tell you right now that there are 2.54 centimeters in 1 inch. Okay? So go ahead and try that one by yourself. If the sub could pause this, give them about, I don't know, 3 or 4 minutes. Okay? Alright, now that you are back, which I hope you are, we're going to do this one together. Okay. One. Let's extend that a little bit. Okay. So we are going to start with what we know. We know 8.92 feet. Okay? Now we need to get out of feet, so we're going to have feet on the bottom here, but we need to get into, what do we know we need to get into? I know inches in a foot, okay, and I know centimeters an inch, so that's going to get me into metric units, so that's probably a good way to start. So for every 1 foot, I know that there are 12 inches. Okay, so now I know from my conversion factor there that for every 1 inch, there are 2.54 centimeters. Now my inches will cancel out. Now I'm in centimeters. So now I'm going to have centimeters on the bottom, and I'm going to convert into my non-prefixed unit, so meters. So I know that there's 1 times 10 to the 2 centimeters in 1 meter. And then I know that for every 1 meter, to get to the number that I'm looking for, or the unit that I'm looking for, which is millimeters, I know that there's 1 times 10 to the 3 millimeters because of my number line. Okay? So let's try and follow that. So I had feet, I put 1 foot down here, I was able to cancel out feet, and I got inches. Then I put 1 inch down here, I was able to cancel out my inches, and that got me into centimeters, because I knew that conversion factor. I can go from centimeters into meters, because I know the conversion factor of 1 times 10 to the 2 centimeters in 1 meter. And then I can go from meters into millimeters, because there's 1 times 10 to the 3 millimeters in 1 meter. Because remember, 1 meter is bigger, so there should be many small things. That's why centi and milli was positive exponents. I end up with millimeters. Alright, so next I'm going to type in into my calculator, parentheses, 8.92. Actually, I don't need parentheses here, so you can just say 8.92. So I'm going to do this on my calculator, 0.92. I'm going to say multiplied, so times by 12, right? Because 12 inches is on the top, so I'm multiplying times 12 times 2.54, oops, times 12 times 2.54, because that's also on the top. Okay, I've got 1 times 10 to the second on the bottom, so I'm going to say divide, and then I'm going to do parentheses, divided by parentheses 1, and then I'm going to hit that times 10 to the n button, but I'm in the, and then in the flashing square, I'm going to type 2, arrow right, to get out of that superscript, parentheses, and then times, open parentheses, 1 times 10 to the n, oops, 1 times 10 to the end, and in the flashing, I'm going to put a 3. Sorry, I'm trying to do this everywhere. Arrow right, close parentheses, and then enter. And what you should get is 2,718.816, which from my question only had 3 sig figs, so my answer should only have 3 sig figs. So I could say 2,720 millimeters, or 2.72 times 10 to the 1/2 millimeters. Now, you can always check yourself too here for whether or not you use the correct signage. And you can do that by looking at your answer. So if I look back at this example where I started out with something that was small, nanograms. I started out with a lot of nanograms and I was trying to convert it into kilograms. So am I going to have more kilograms than I do have nanograms? Or am I going to have a fraction of a kilogram for how many nanograms I have? And the answer is I should have a fraction of a kilograms, a fraction of the larger thing for many small things. Okay, so let's think about it in terms of feet. If I have 8.92 feet, which is a lot of feet, I should have a lot of millimeters because feet are really big. So if I have 8.92 feet, I should have thousands of millimeters because they're so much smaller. So if I look at that, I have 2,718 millimeters. That makes sense. Okay. Okay, so let's try one more problem together, and then I'm going to send you loose to work with each other on figuring this out. So this next one is going to be the hardest one yet. But don't freak out. You'll be fine. There's only, I think, one of these in the worksheet that I'm going to have you guys do. So if it makes no sense, we'll work on it when I come back. But I want you to convert 6.8 times 10 to the 6th. And here's the tricky part. Meters per second. I want you to convert that into feet per hour. Okay, and remember that there are 2.54 centimeters in 1 inch. Okay, so this is the weirdest one yet, and it's because we've got that whole idea of meters per second. You've got what I like to call a double unit. Okay. So you've got a unit over units. So let's start with what we know. We know 6.84 times 10 to the positive 6. And here's going to be the biggest difference from before. Meters, okay, so that's how many meters there are. And when it says meters per second, it means meters per 1 second. And so that 1 second per means divided by. And so that 1 second is going to go on the bottom. Okay? 1 second goes on the bottom. So now I have meters per second. And I need to get it to feet per hour. And so the way that we do that is we just take it 1 unit at a time. It doesn't matter which unit it is. It's just 1 unit at a time. So we can start with meters or we can start with seconds. It doesn't bother me. So let's start with the meters since that's what we're familiar with. The thing that's on top. So if we want to get rid of meters, we need to put 1 meter on the bottom. We need to put meters on the bottom, which it's our base unit, so we're going to have 1 of them. So 1 meter on the bottom, and I'm trying to get to feet. But I see here that I can get from centimeters into inches. So I should probably get into, and because I know I can get from inches into feet. So let's get us into centimeters first. So I know that there's 1 times 10 to the 2 centimeters in 1 meter, number from our note card. So now my meters are gone, I have centimeters. So I need to get rid of them, so I'm going to put them on the bottom. So centimeters goes on the bottom, and this time it's not a 1 times 10 to the 2, it's my conversion from metric to non-metric, so 2.54 centimeters goes on the bottom, and then on top we're going to say 1 inch. And then just like we did before, we remember that there are 12 inches in 1 foot. 12 inches is going to go on the bottom, 1 foot's going to go on the top. So, if you look, we've managed to cancel out meters, centimeters, and inches. And we're left with feet on the top, which up here, feet was on the top of my fraction for feet per hour. So that's good. That's where we needed it to be. We needed it to be on the top. Okay? So we've got our feet. So now we just need to get our hours from seconds. So let's think about that for a second and how we would do that. Now, I'm sure some of you are really good and you know how many seconds are in an hour, but you've seen me do this. I like to take small steps. So I know that there are 60 seconds in a minute. Now, here's the trickiest part. The seconds are on the bottom now. So if I want to cancel them, I need to put seconds on the top. I cannot put seconds on the bottom or I will never cancel it out. So I'm going to put 60 seconds on the top. And this is the thing that people forget the most. And it is the reason why they'll get the problem wrong. So make sure that you put it on the top. Okay? So 60 seconds, and that is in 1 minute. And I put minute M-I-N because 1 M is 1 meter. So 60 seconds in 1 minute. Okay, and then I know that there are 60 minutes in 1 hour. And minutes goes on top this time because we're trying to cancel out something that was on bottom. So let's take a look back at that. We canceled out seconds with seconds, minutes with minutes, and we were left with hours on the bottom, which is actually where we needed it to be. Ho-ho, it's like magic, or that I know what I'm doing. Either one of those, I'm not sure. So we end up with feet per hour. And then in our calculator, and this one's going to get tricky because we got a lot of stuff going on, but remember, if you're using scientific notation, you need to use parentheses. So in your calculator, you're going to type, you're going to type parentheses 6.84, and that times 10 to the n, and in that flashing box, you're going to put 6, and then arrow right with your gray oval, close parentheses, and then I'm going to times it by, so times parentheses, because I've got 1 times 10 to the 2 on top, so times parentheses 1 times 10 to the n, and this time it's going to be a 2, arrow right, close parentheses, and then 2.54 is on the bottom, so I'm going to say divided by 2.54, and then I'm going to say 12 is on the bottom, so divided by 12, and then I've got 60 on the top, so times 60, and then another 60 on top, so times 60. And then hit enter, and you get 8.078740157 times 10 to the 10th. And that should be feet per hour. But we didn't start out with that many sig figs. We only started out with 3, so we should have 3 sig figs in our answer, so that should be 8.08 times 10 to the 10th feet per hour. Alright, like I said, I want those of you who took Chem Lab methods, or those of you who've seen this before, please help other people. Please use that note card that I had you redo. Use the positive numbers for the small ones. I know there are some of you who are going to really really rebel against that, and that's okay, but I'd like you to hold off until I'm back before we can talk about that. Thank you guys for being willing to work with me. I don't think I could do this 5 times tomorrow. It took all of my energy to do it once. So I will see you guys hopefully on Friday. Fingers crossed. I'm going to sleep all day tomorrow. Be nice to the sub, and I'll see you soon. Thanks.